Welcome to another edition of Toolbox Tuesday. Today we're going to look at some tips that you can use while you're doing an air conditioning tune-up. The whole idea here is that we're going to clean the system and check everything around it, and check all of the components that operate the system. So today in our lab, we're just here on the heat pump. So I'm going to go through some of the things that you'll do on a standard straight AC, and also some of the things that you may do on a heat pump. Well, let's talk about the cleaning part. The first thing that we want to do is check all around the outside and the exterior of the condenser unit to make sure that there's no grass, no leaves, no debris that may have gotten caught up in the fins and different things like that. All of that stuff can actually prevent and restrict airflow that is coming across that coil. We need the airflow to be uninhibited as it passes across the coil. That's because that's a major part of our condensing process and our condenser's ability to go ahead and then reject heat out of the top. One of the other things that we have to make sure of is visually we want to check our refrigerant lines and see if there's indications of oil. If we can see oil somewhere on our refrigerant lines or even on the wall plate there, a lot of times that can be an indicator just from sight that we may have a possible leak in our system. Now, when it comes to cleaning, another area that you want to check is actually to remove the top, or to look down and peer down inside and look at the interior, the inside of the condensing units. A lot of times leaves and different things like that and other types of debris, sticks, may fall into our unit, and we want to actually vacuum all of that stuff out, scoop all of that stuff out, and make sure the inside of the unit is cleaned as well. Now, when it comes to cleaning the coils, there's a lot of products out on the market that your local supply houses may have. Your company may stock your truck with one that they recommend and they use. But one of the things that's important is we definitely need to have a conversation with our homeowners about how often they should clean their coils. Now, a lot of people may not want to do that themselves, and here's a great opportunity for the technician to say, hey, this is a good reason for you to be a part of our preventative maintenance program, where we can come out a couple times a year and actually check that for you. Also, you have to educate the homeowner that the sprinkler that comes on is not the proper way to clean this coil. So just because they have a sprinkler system doesn't necessarily mean that their coil is getting clean. And another reason is we all, especially here in Texas, we all want to have these nice, beautiful lawns that are maintained and mowed once a week, sometimes twice a week, sometimes every other week. And every time that happens, be it from ourselves and or our neighbors, we can find a situation where our coils have now gotten impacted with all of that dirt and debris. So once we've checked the outside of that coil and got everything taken care of there, we have a couple other things inside of our unit that we also need to check. One of them is our contactor. Now, depending on what kind of contactor you have, the top part may be enclosed with a little shield to kind of prevent or keep things from getting out of there. Sometimes, I don't know why, but sometimes ants get collected in there and they could actually stop the contacts from making contact. A term that you'll hear in our industry a lot is the term pitted as it relates to contactors. And when you look at it, you'll see a lot of blackening from arcing of those contactors hitting or chattering together. And if that happens and it becomes too much of a buildup there, then those contacts won't make contact and our contactor won't be able to do its job and actually allow our unit to come on. So you need to check the integrity of our contactor. Another item that you'll check is your capacitor. Now, once you do that, the great thing about these capacitors is they have a level here recommended by the manufacturer as when the manufacturer says this capacitor is good or bad. Sometimes you can have a capacitor that is outside of manufacturer specifications, but still operational. And there's a huge skill set here that's needed for the technician to be able to have a conversation with the homeowner as it relates to an operational capacitor that's testing below manufacturer specifications. So you're going to use your voltmeter here, your multimeter. Make sure you go to the proper setting for capacitance. This one happens to be the actual symbol right? But your meter may be set up different. Some of them MFD or whatever the setting is to check it. Now, there's two ways that people check it in the industry. And one of the ways is to actually turn the system off, disconnect the capacitor, and then take your probes and check it there. But you can also check your capacitor while the system is running by taking an amp draw on the capacitor, multiplying that amp draw by 2650, and dividing that by the voltage. You can also take a voltage on that capacitor. And if you look at the label, that voltage you'll be reading there, but you can take it while running and get an actual voltage. You do the math, which is 2650 times amps divided by voltage, and you'll get a capacitance reading there as well. So that way you can check it without ever disconnecting. I know a lot of you may not have done it that way, and it's always a great surprise to know that you can do it that way. But when I was a field technician, I didn't do it in the field that way, but when I learned that you could do it that way, it was pretty amazing. And what you'll find is when you check it under load, a lot of times it'll be just a hair lower than it is if you check it or if you disconnect it. So checking your capacitor. There's another capacitor that you also need to check, because our indoor blower motor, which is located inside of the house now, also has a capacitor. If it doesn't, and it's a variable speed or ECM motor, then we may have to use one of those testers to test that. But don't forget to check our indoor unit as well. Now, since we've traveled back inside to check our indoor unit, we also need to go ahead and check our indoor evaporator coil at that time. Make sure that it's clean, make sure that it doesn't have any blockage or dirt or debris. And if it does, we may want to have a conversation with our homeowner as it relates to UV lights or some type of protectant that we can put in there to kind of help keep that down. And couple that with, maybe we need to talk about our filters. Got to check our filters and make sure our filters have been upgraded, make sure our filters are clean, and we've got a good filtration going through our entire system. As we come back out to our condensing unit, we'll notice I've got my gauges hooked up. My system isn't running, but we're just using this for demonstration's sake, but I have my gauges hooked up. You have my temperature clamps there. You'll want to put these in a good place and make sure that you kind of catch it before a bend if you can. Sometimes, depending on how the condenser unit was installed, that's not possible, but you also want to take a look at that. All right, but anyway, we'll have our temperature clamp set up, we got our gauges set up, and now we're going to calculate superheat and subcooling. We can take our superheat number and our subcooling numbers and make sure that they are within tolerance of manufacturer specs to ensure that our unit is operating at maximum efficiency. One of the things that you have to check is when it comes to subcooling, sometimes on the data plate, it'll tell you what that range, that number should be. It'll say plus or minus, 3 degrees subcooling or plus or minus 4 degrees subcooling, right? So you want to make sure that when you get your subcooling number, you're there. The same thing with our superheat. Now our superheat is going to be determined how we look at that number based on whether or not we have a fixed orifice metering device or if we have a TXV as our metering device. Those two numbers are going to vary based on which type of metering device we have in our system. We know that a TXV is designed to maintain a constant superheat of 10 to 15 degrees. So by that, we're going to charge our system by subcooling because our TXV is going to try to regulate the temperature for us. So we have to make sure that we understand this particular process in our HVAC AC cleaning checks, or tune-ups rather, because it's vital to let us know what is my refrigerant actually doing within the system. So make sure we calculate our superheat and subcooling numbers accurately to make sure that our system is operating at optimal performance. Any adjustment or any error in those numbers may require that we need to add refrigerant or remove refrigerant, and it could be an indication that we have a possible bigger issue as it relates to refrigerant that we need to check. So the other thing is, you'll notice that we have a circuit board in here because this is a heat pump system. So there's some test pins and some defrost mechanisms that you could test on your board to make sure your defrost cycle works properly on your heat pump, and also make sure that you connect on your heat pump to the true suction port, not necessarily the suction port, but the true suction port located on on the systems. So you'll notice right up under here, there is our true suction port for our heat pump. So if we were checking it in heat pump mode or a heat pump, we want to make sure that we hook up to the right place. So after we've cleaned everything, we've checked all of our components. Remember, there's some amp draws and different things like that to make sure our motors are working within tolerance, to ensure that our condenser unit on the AC side and our matching evaporator core are all healthy, that they're working great, and that our homeowner is going to be comfortable in their house. These just cover a few things that we need to check, not necessarily all of them, and depending on your company and where you work, you guys might do something a little different. Please comment below. Let us know some of the things that you do on your AC cleaning checks that gives great customer service, or things that you really think are just functional and that everyone should do on a cleaning check. After all, it's one big fraternity of HVAC technicians, and we can all learn from each other. I look forward to speaking with you again. Thanks for tuning in to another edition of Toolbox Tuesday, and we'll see you next time.